you haven't already done so, please put your name in chat. Oh, shoot. I just realized.
Professor Reed.
Yeah, my device picked this particular moment in time to update. So hopefully, oh, is it done? Cool. Let me see if it'll talk to it. I may have to switch my Wi-Fi. Let me see if my device will talk to the school's Wi-Fi. Oh my word. It let me do it. Okay. Let me see if it will. pull up the PowerPoint. Jeez. There we go. Let's back up. I'm on campus, so it's taking me a little bit longer to get things set up here. And I may have to switch Wi-Fi networks. I'm currently on the school's network. I may have to use my phone as a hotspot if it won't let me sync. Yeah, it's not letting me sync. So I'm gonna have to, it'll take me a little bit here, but just bear with me. Hopefully it won't interrupt the. All right, says my internet is unstable, but Oh, he left. All right. All right. Are there any questions? Oops. Are any questions about anything so far? Please be sure you're in MyLab. Some of y'all will be getting early alert progress reports concerning the fact that your progress through MyLab is lacking. Need to get in there and start doing the work. There are a few people who haven't done any work. There are a few people who've only done one lesson or part of one lesson. And then a number of people who have moved on. Okay, my audio is getting scratchy, you said?
Yes, your audio is kind of hard to hear.
What now? Did that affect my volume at all?
It's better.
Okay. I was just microphone. There we go. On the microphone. And, how's that? Is that better?
Professor, I honestly think it's your internet as much as the audio is scratchy. Your video feed is also somewhat stuttery.
Yeah, it's I'm this is my Wi-Fi connection. Because I can't do what I do through the school's network. So yeah, it's kind of, let me know if it gets real bad and if I need to repeat things. In the past, it's worked okay, but that was in the past. So things change. Okay, now let me, here we go. Start the share. Okay. I believe this is where we left off last time. Let me pull the chat back open.
I think we're a few slides behind that.
Say again?
I think we're a few slides behind that. I don't think we finished 6.3.
Okay. we talk about odd and even properties?
Yeah, that's the last thing I have in my notes.
Okay. Oh, I see the problem. All right. Yeah, odd and even. Even means when you do f of negative x, you get f of x. It's even. And that means it's going to be symmetric with respect to the y-axis. With odd, when you do f of negative x, you get the negative of f of x. And it's going to be symmetric with respect to the origin. Okay, so what this is saying that if I do sine of a negative pi over 3, that's going to be the same as the negative of the sine of pi over 3. So we don't typically take the trig functions, we don't do it on negative angles because we pull the negative sign out. And if it's an odd function, the negative sign comes out as negating whatever value we get. And with cosine and secant, negative pi over 3 is the same as the cosine of pi over 3. And same thing is true with secant. All the others are odd functions. The other 4 functions are odd. So if you have a negative inside that function, you can pull it out and make it the negative of the function of the even angle. I mean, of the positive angle. And if it's cosine or secant, if you're taking it of a negative angle, then you can just drop the negative angle and just make it positive, and it has to do with the symmetry aspect of with cosine. These two angles have opposite sine values, but these two angles have the same cosine values. So this is the positive and this is the negative. Where with sine, it's the sine of this angle over here and the sine of this angle down here. The y values are going to be opposite signs. So the sine of the positive angle is the negative of the sine of the negative angle, and vice versa. So sine of negative 30 is going to be the negative of the sine of 30. The cosine of pi over 3 is going to be the cosine of pi over 3. Cotangent of negative 5 pi over 4 is going to be the negative of the cotangent of 5 pi over 4. And same thing with tangent. So it'll be the negative tangent of 29 pi over 4. Questions there? Okay. So now for the graphs. we're going to look at the graph of the sine function, and then the function, then the graph of the function of the form a sine omega x. Come on. Yeah, this is omega x. And we have names for these, for what they do. These numbers have specific effects on the graph. And then we're going to look at the cosine, the graph of the cosine, and y equals a cosine omega x. We're going to determine amplitude and period of sinusoidal functions. Sine and cosine are considered the sinusoidal functions because they both are very much alike. And then find an equation of a sinusoidal graph. So if we have a graph that's sinusoidal in appearance, we can write an equation that fits it. Okay. All right, so we want to graph trig functions in the xy plane. We use traditional symbols for x, the independent variable or argument, and y for the dependent variable for each function. The 6 trig functions are written as such. Okay, so instead of using theta, we use x, and it equals y. All right, so if we look at this, so here we have x, which will be along here, and so we have what do I use? I use 0, pi over 6, pi over 2, pi use 0, pi over 6. Let me see. Pi 7 pi over 6, 3 pi over 2, and 11 pi over 6, and 2 pi. All right. And then we just find sine of x, which is the y value. So if we remember from the unit circle, we're looking at the y values of these points that they're asking about, the y values of these points. Okay. Well, that one's a little low. It should be about here. So that one will be about there. So the y value here is 0, and the y value here is 1/2, and the y value up here is 1, and then it starts coming back down again. So this is going to be 1/2, and this will be at 0 again. And now we're going in the negative direction. So this will be negative 1/2, and this will be a negative 1, and this comes, and then it starts coming back up again. And so now it's going to be negative 1/2, and then back to 0. So we went full circle. Well, so we graph these ordered pairs. Here we have 0, 0, and then pi over 6, which is going to be about here, is at 1/2. And then at pi over 2, it's at 1. And then at 11 pi over 6, it's back to 1/2. And then it's at 0. And then we go back down to negative 1/2. Whoops. Yeah, negative 1/2, and then down to negative 1, and then back up to negative 1/2, and then at 0, and then back to 1/2, and then back up to 1. And so you have this pattern here. Oops. Hit it when my hand twitches and I'm trying to draw a line or a curve. And then it goes back this way doing the same thing. Okay. But this graph here is restricting our x's between 0 and 2 pi. And so here we have this curve. This curve is what we call sinusoidal. It is also periodic. It means it keeps happening again and again. So from here, let me see. So from here to here, and then if we pick this up and move it over, it starts repeating again and again. So the period is between 0 and 2 pi is our period, because I can just cut that out and paste it again and again and again, beginning to end, and it just keeps going. That's why it's called periodic, because it keeps going through those values from -1 to 1 over and over again in the same period. Okay. The domain is all real numbers. The range consists of real numbers from -1 to 1 inclusive. They say inclusive because it can equal -1 and it can equal +1. The sign is an odd function. So the sign of 1/2 or the sign of -1/2 is the negative of the sign of, negative pi over 2 is the negative of the sign of pi over 2. Sign of pi over 2 is 1, so the sign of negative pi over 2 is -1. Okay. And let me say, the graph shows that it's going to be symmetric with respect to the origin, because it goes that pattern this way, it does the same thing going this way, and if you rotate it 180 degrees, they'll line up with each other perfectly. The sine function is periodic with a period of 2 pi, and the x-intercepts are the multiples of pi, the multiples of pi. The y-intercept is 0 right there. So we see that. The maximum values occur at well, it's a pattern to how they're showing up. So here's the maximum. So the maximums at 1, at pi halves, at 5 pi halves, at 9 pi halves. So every pi over 2, starting at pi over 2, going positive and negative, it's going to be 1. And the minimum values, which are -1, occur at the same rate, but it's going to be 2 pi, a multiple of 2. They're a multiple of 2 pi apart. So that's adding multiples of 2 pi or subtracting multiples of 2 pi. Going to be 2 apart. So that's adding multiples to -pi/2.
Sir, can you say that one more time, please? Your mic was going in and out.
Okay. Let me write it down. Maxes occur at pi/2 plus 2 pi k, where k is any integer. And the mins occur at -pi/2 plus 2 pi k, where k, again, k is any integer. So the maximums are there, they are going to be 2 pi apart, where the minimums, they also are going to be 2 pi apart. The next maximum over here is going to be here, and that's 2 pi. That making sense? So that's what this is saying for the maximums and for the minimums. We start with either pi/2 for the maximums or -pi/2 for the minimums, and then we add a multiple of 2 pi to it, either a negative multiple or a positive multiple. Realizing 0 is a multiple of any number. Because 0 times any number is 0. That clarify?
Yes, sir.
Okay. And with cosine, we're gonna have the exact same deal, except where the minimums and maximums are is going to be different. Okay. Geez, I didn't mean to do this. Hang on a second. I have to do something real quick. No, that's not what I wanted. Mhm. Shoot. Well, let me see. Okay. Now, well, 3 times sine of x means I'm multiplying the sine values by 3. So 3 times 1 gives me 3. So now my maximums are now up at 3, and my minimums, instead of being at -1, now they're down at -3, because I'm multiplying by -3. Yeah, I got another one down here. This one up here. And then so then I have this going on. And going back this other way, it's going to be doing the same thing. Okay. And so that's what y assign y equals 3 sine of x is. If we look, we have key points here, key values. The key points are 0, 0. And going back to the y function, the sine function. Whoops, I didn't know what I meant to do. These values, these points here are our key points. So we have 5 key points. 0, 0, that's this one. And then this one here is pi over 2, 1. And then the next key point is this one here at pi 0. And then this one here, which is at 3 pi halves 0. Actually, that's -1, sorry. -1. And then back to here at 2 pi, we have 0 again. These 5 key points of the sine function. Sine is periodic, and its period is 2 pi. So at 2 pi, the numbers start repeating again. So at 5 pi over 2, it's going to be at 1, and at 3 pi, it's going to be 0. And then at the next half pi, it's going to be -1, and on and on and on. And so that's, and at 3 pi of 1, and on and on and on. And so we have that. Okay. So using transformations, you multiply the y values by 3, and the x values remain the same, because the 3 happens after the trig function. The trig function gives us our y, and then we're going to multiply that y by 3. So this y value here got multiplied by 3 and brought up to here. Same thing over here. Same thing here. So all these y values got multiplied by 3, and they moved by a factor of 3 away from the x-axis. So this is a vertical stretch. We multiply a term function by a whole number greater than, or by any number greater than 1, you get a vertical stretch. You're pulling it away from the x-axis. Okay. But at 0, it's going to stay 0, because anything times 0 stays 0. And our range, our domain remained the same. Domain didn't change, but the range did, because instead of going down to -1, now it's going down to -3. So we go from -3 to +3 in terms of our range, all our y values, the values we get out of the function. Okay. So now we have this function. It's going to be a similar deal. All right. So I look at 0, and 2 times 0 stays 0. Now I look at 1/2. If I multiply 1/2 by 2, that gives me pi. So that brings this one down to here. And I multiply pi by 2, that brings this 2 pi down to here. And so what that did was it cut my x values in half. So I have, if I look at my key points, 0, 0, damn it, pi over 2, 1, pi, 0, damn it, what is that? 3 pi over 2, -1, and 2 pi, 0. And I'm trying to figure out what they do first. Oh, they look at the y equals a -2 sine of 2x. So they're going to look at what happens to the y values. The y values, instead of going up to 1 and down to -1, now it's going to go up to -2 and down to -2, because going down to -2 and up to +2. So it switches where our maximums and mins are, and it's going to switch how far down it goes. So now it's going to go down to a -2. So this will be 0 times -2 is still 0, and the -2 times 1 is going to be -2, and then -2 times 0 is still 0, and the 3 pi over 2 -1 becomes 3 pi over 2, 2, because -2 times -1 is 2, and then -2 times 0 stays 0. Any questions on what was done there? Textbook looks at it a little different than I do. So instead of the function going like this, right, where it comes up and then comes back down again. Oops, let me hit there. And then comes all the way down to 1, -1, and come back up to 0. Now it's going to go, it's instead of coming up to 1, it goes down to -2. Comes back. Let me change that. So now it's coming down to -2, and then comes back up to 0, and then goes up to +2, and comes back down. Okay. Now we're going to change our x values, because now I want to know what do I multiply by to get pi over 2? Well, pi over 4, if I multiply pi over 4 by 2, that gives me pi over 2. So now instead of going instead of pi over 2 taking us down to -2, it's going to be pi over 4 taking us down to -2. And now pi over what do I multiply by to get pi? If I'm multiplying something by 2 to get pi, that means x is pi over 2. So to get 0, x has to be pi over 2. So that's going to be pi over 2 is going to give me 0. So it is going to come back to 0 here. And 0, 0 stays going to 0, 0. And that's not going to change. And now to get 3 pi over 2 by multiplying by 2. So that means I need to multiply 3 pi over 4 to get 3 pi over 2. So instead of being up here at 3 pi over 2, now we're back over here to this value, 3 pi over 2, and that brings us up to 2. And then we multiply pi by 2 to get 2 pi. Let me write this here. The 3 pi over 4 gives us 2, because 2 times 3 pi over 2 is 3 pi over 4 is 3 pi over 2. And if pi, if I multiply pi by 2, I get 2 pi, which is the 0. And so instead of being here, now it's down over here. So press towards the y-axis. And the same thing is happening on this side. Oops. Change that size. So now it comes down like this. So now these are the key. So these are the key points, the 5 key points for this function. And what they did, they talked about, what did they do? What was the first thing they did? They multiply by -1. They take care of this negative sign. So they flip this oops. They flipped across the y-axis here. Okay. And then they multiplied it by 2. So instead of being at 1, now it's at 2. Instead of being at -1, it's now at -2. Okay. And so it's a horizontal compression of 1/2. So I'm multiplying, basically what they did, they multiplied each of these x values, pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. They multiplied it by 1/2. A half of 0 is still 0. A half of pi over 2 is pi over 4. A half of pi is pi over 2. A half of 3 pi over 2 is 3 pi over 4. And a half of 2 pi is pi. It'll be a little less confusing after a moment here. We'll look at a more systematic way of looking at these things to come up with a new graph. All right. Now, what's showing us next is a cosine function. The cosine function has a name. Uh, the y value has the same y values from -1 to 1. It's just now instead of starting at 0, 0, it starts at 0, 1, and then goes down to 0, and then down to -1, and then back up to 0, and back up to 1, and then continues that process. It also has a period of 2 pi. That means from 0 to 2 pi, it covers all the values it's going to cover as far as the y values are concerned. And then it just repeats those numbers over and over again as x gets bigger or as x gets smaller. All right, the domain is all real numbers, and the range, just like with the sine function, the cosine and sine function have the exact same domain and range. The domain is all real numbers, and the range is all real numbers from -1 to 1, including -1 and 1. The cosine function is even, and it's symmetric with respect to the y-axis. All right, if we come back here, I didn't draw it out. But if we look at the previous slide here, this point has a mirror image over here, and it's across the y-axis. So cosine is periodic. It has the same here. The sine has the same period. Secant and cosecant all have the same period. Pi, tangent and cotangent have the same period, which is pi. The period for sine and cosine is half that of sine and cosine. The cosine functions like with sine. The x-intercepts are the multiples of 2 pi, or the odd multiples of 2 pi. 1 and -1 are the 1 and 2 pi. Cosine. -1, -3, multiply 5, like with sine, but 5 and -5, the x of 2 pi, the odd multiples of 2 pi. 1, 3, and you will get negative where it crosses the y-axis. The supply pi over 2 by those numbers. Yeah, the x-intercepts at 1, the x-intercepts at, so your intercept is at 1, the x-intercepts at are that, yeah, because the half, yeah. And yeah, the x-intercepts, and then the maximum values occur at the even or pi, even multiples of pi intervals. You hit the y or at the half, and then the max at the odd multiple, and maximum values occur in multiples of pi. You hit the one, the of this sucks. A lot of skipping and stuttering. Let's see what's going on with my phone. Oh, jeez. Okay, hopefully that'll help a little bit. So is that any better?
Audio is better at the moment, Professor.
Yes.
Okay. The maximum values occur at the even multiples of pi, and the odd, and the minimums occur at the odd multiples of pi. And it has a period of 2 pi, just like cosine does. Or cosine would go like this. And sine would go, this would be sine, and this is cosine. They're half a pi. They have a horizontal shift of half a pi. And when we're talking periodic functions, the sinusoidal functions, people who know audio stuff, this is what we call a phase shift. A horizontal shift is for sinusoidal functions is a phase shift. So we're just shifting it to the left or to the right, basically, is all we're doing. So using transformations, get rid of this guy. So this is my cosine, and they want to look at the transformations on this function. All right, I will do the 2 times first, because now Now, 2 times the maximum takes us up to 2. 2 times the minimum takes us down to -2. And 2 times 0 stays at 0. So this is what happens here. Okay. So it keeps it, and that's what happens there. And now the 3 times x inside the argument. So we have y equals 2 times cosine of 3x. So when you're multiplying by 3, that means we take the x values and multiply the x values by 1/3. So I multiply 2 over pi over 2 by 1/3. So that'll give me, so pi over 2 times 1/3 gives me pi over 6. So this point gets moved back to about here. So that got moved back to here. And now this point down here at pi, I'm going to multiply pi by 1/3. So that gives me pi over 3. So this gets moved over here to pi over 3, which is about here. Pi over 3. So this point got moved back here. And then 3 pi over 2, we have 3 pi over 2 times 1/3, which gives me pi over 2. So this point got moved all, this point here got moved all the way back to here. It's still 0, but now the 0 is over here instead of over there. And now we're going to move this point that way because we're going to multiply 2 pi times 1/3, which gives us 2 pi over 3. So this gets moved back to 2 pi over 3, which is about here. And so this point gets moved all the way back to here. So now it goes through these points and increase the frequency. So this graph here got compressed towards the y-axis. So if you go in the negative direction, this function, again, everything got pushed towards the y-axis by multiplying each x value by 1/3. If you remember from college algebra, if you're multiplying the argument x by a number greater than 1, you're creating a horizontal compression. And if you're multiplying by a fraction less than 1, then you're doing a horizontal stretch. You're pulling it away from the y-axis. And now the period, instead of going from 0 to 2 pi, now it goes from 0, it went from 0 to 2 pi over 3. So that's the period. Because we shrunk the period by multiplying it by 1/3. Okay, they multiplied by 2. They multiply each y value by 2, and then they multiplied each x value by 1/3 and kept the y value the same. Yeah, please realize that the scale of these two graphs is different. Right, it would have been much more compressed here. Because all they basically did was change this 1/2 to pi over 2 to pi over 6, and this one pi to pi over 3. So it's basically the same graph. They just changed what the x values were. They're not showing the compression. Come on. There we go. The domain remained all the real numbers. So if you're changing things in a function like the sine and cosine functions, you're not going to change the domain. The domain is going to remain all real numbers. Okay. Something might happen that it'll change the domain, but in most 99% of the time, especially in this class, the domain won't change as far as for sine and cosine. For the other trig functions, it will. But for sine and cosine, it won't. And the range changes based on what you're multiplying it by. And if you have any vertical shifts, if it shifts up or down, then it's going to change your range. If you're multiplying the sine or cosine function by a number, then it's going to change what your maximum and minimum values will be. And so it will change the range. So that's why in this case, the range is from -2 to +2, including -2 and +2. All right, the period of the function is 2 pi over 3, which is what I said, what I had said here. What I had said here. That looks like a weird face. Something bizarre going on with this guy's eye over here. Okay. So, well, here they show the compression. When they graph them, graph both of them on the same graph, you can see the compression. That this point got shoved all the way back to here and bumped up, and this got bumped down all the way back to here. And this point got moved all the way back to here. So you see the compression. You also see the vertical stretch. All right, so cosine is a sine is a phase shift of cosine, and cosine is a phase shift of sine by pi over 2. You add pi over 2 to the x in sine, and you'll get the cosine. You subtract pi over 2 from the x in cosine, and you'll get sine. Okay. They're out of sync with each other by half a pi. And I like this graphic here because it shows that very clearly. That if I move the cosine I move the cosine up pi over 2, I'll get the sine. And if I move the sine back pi over 2, I'll get the cosine. All right, omega. Here we have omega. Omega helps us find the period. The amplitude helps us find the range, maximum and minimum y values. Okay. So once we find out what omega is, we can find the period. The period t is 2 pi over omega. If I just did sine of x, then omega is 1. So that's 2 pi over 1, which is 2 pi. And the period of sine is 2 pi. But if I start messing with x, that will change my period. Okay. Multiplying by 3 is dividing by, is multiplying in here by 3 is dividing the period by 3. And the amplitude is just tells you how high and how low it goes from its baseline. So for this, the baseline is going to be 0. Okay, so the A value of A up here and negative absolute value of A down here from the baseline. Okay, if I have a plus or minus something at the end here after the cosine or after the sine, from minus something shift. And so that's moving my x-axis up or down. So I'm moving my baseline up or down. So the amplitude is about where you wind up for your zeros. Okay. You look at where your x-intercepts wind up because they'll get moved. And so that'll be your new x-axis for this function. So it's going to be the amplitude above and amplitude below. All right, so here I have y equals 5 times the sine of 3x. So I need to identify what a is so I can find out what the absolute value of a is. And then I need to determine what omega is so I can determine the period, which is 2 pi being divided by omega. All right. So what's a?
5.
5. So what's the absolute value of a, which is the amplitude?
5.
5. What's omega in this case? What is x being multiplied by?
3.
And so what's the period?
Two pi over 3.
2 pi over 3. And yes, it is that simple. So this, instead of going from here to here in one period, now it's going to go from here to here. Three pi, 2 over 3 pi. Two pi over 3, sorry, 2/3 pi. So it's going to hit its maximum and minimum in this period. And it's going to hit 0 3 times in that period. So my maximum is up to 5. So at pi over 2, it's up here at 5. This is 4 and 5. So it's all the way up to here. 3, sorry. Minimum is all the way down here, and it goes all the way down to -5. So 4 and 5, all the way down to here, and then back up to here. But now, because I'm going to multiply, I'm going to multiply each one of these by 1/3. So now pi over 6. Pi over 6 is about here. Right? Wait a minute. Yeah. So 0 stayed 0. Pi over 2 became pi over 6 and pi over pi, I mean just pi now becomes pi over 3, and 3 pi over 2 becomes pi over 2, and not equals. It becomes, because once you multiply by 1/3, and then the 2 pi becomes 2 pi over 3. So pi over 2 was associated with 1, now it's associated with 5, so this is going to be 5 here. So at pi over 6, so yeah. Halfway, halfway, halfway. Okay. Actually, this isn't correct. My scale is off a little bit. I don't know why, but it is. It is going to be down here and right about here. And so okay, so we have 1/2, and then here we have 1/3, and then we have 1/6. And so now this is up here, and this is here, and this is down here, and this is here. So now it comes up like this, and drops all the way down like this, and then comes back up like this. Pi over 3 is back to 2, and pi half is 5, and 2/3 pi is back at 0, and 0 is at 0. Okay. And so they identified A and omega, and then the amplitude is 5, and the period is 3 pi over 2 omega. The period is 3 pi over 2. Talk about using the period. So the period, okay. No, oh, they didn't want us to graph it. They just wanted to find these values. Okay. I went ahead and tried to graph it. Okay, find the amplitude and here to the function, and here they want us to graph that. And so I look at what the key points are. For sine, the 5 key points, 0, 0, pi over 2, 1, pi 0, 3 pi halves, 3 pi over 2, -1, and 2 pi 0. So there we have those key points, right? It's the half values starting from 0 up to 2 pi, because those hit your x-intercepts, and they also hit your maximum and y and minimum y values. Now the amplitude for this, we have y equals 0 2 sine 2x. A is 2, which means the absolute value of A, which is the amplitude, is 2. So our maximum and minimum y values get multiplied by 2. And so so now my minimum values are -1 and my maximum values are +1. Okay. And now omega in this case is 2. So the period equals 2 pi over 2 pi over omega, which is 2 pi over 2, which is just pi. So now it's going to go, instead of going from 0 to 2 pi, it goes from 0 to pi. And now I'm going to divide this into 4 regions. All right, I take halfway, so that's 1/2 pi. And then halfway between 0 and pi over 2 is pi over 4. And halfway between pi over 2 and pi is 3 pi over 4. And that's the same as adding 1/4 to 1/2. And so now these are my new x values. I'm changing my x values because of omega. Omega forces me to change my x values in my key points. Because if I multiply 1/4 pi by 2, I get half a pi. If I multiply 2 pi by 2, I get pi. So I have to change my x values so I can still get the same y values. So this is going to be the point 0, 0. And this will be the point pi over 4, 1. And this will be the point pi over 2, -1. And this will be the point 3 pi. I'm sorry, that's 0. Pi over 2, 0. And then 3 pi over 4 will be at -1. And then pi now is at 0. So what I did was I did a horizontal compression. So I'm dividing each of the x values by half, so I'm compressing it towards the y axis. Okay. So now instead of these points, what am I doing? Sine. So instead of these points here, now they're being taking half back to here. This one comes back here. Half of this one brings it back to here. Okay, half of this x value bring back to here. So this point comes back to here. Half of 2 pi brings it all the way back to pi. So this point, which got moved, is now being replaced by this point over here. And half of 5 pi over 2 is 5 pi over 4. And 5 pi over 4 is here. So this point got moved back to here. Okay, so now we have this thing. Wait a second. I missed something. What did I miss? Then we got moved back to there. And so that means this one got moved back to here. Yeah. And so it continues on the pattern. Okay. So now I'm gonna deal with this 2 times the sine. I'm doing 2 times the Y value now. I changed the X value appropriately. Now I'm going to change the Y value appropriately. I'm going to multiply each of these Y values by 2 because that's the amplitude. Okay, so now I have 0, 0, and then I have pi over 4, 2, because I'm changing the highest X value from being at 1, now it's at 2. The zeros will stay at 0 because 2 times 0 is 0, no matter how many times you multiply it by 2. And at 3 pi over 4, I'm going to multiply the 1/2 by 2, so that's going to be a -2. So instead of coming down to here, now it comes down all the way down to here. And then it comes back up to 0. Because 0 times 2 is 0. And then this next high will be at 1. Back through 0. And come back down to 2 pi. Down to -2. So now, change that again. So now it goes like this. I still have a period here of 1 pi because I changed my pi because of the omega. Okay, and this is how they look at it. They get the period the same way because the amplitude is 2, the graph lie between -2 and +2 on the y-axis. So that gives us our maximums and minimums. It divides the interval into. We do the same thing in a similar fashion, but I approach it differently. I'm basically what I do. I look at a number line, and so I determine that it's from 0 to pi is pi over. We do the same look at a number line. That's from 0 to pi half. And so each of those is going to be a fourth of a pi. So this is 1/4 pi, and this is 2/4 pi, or pi over 2, and then 3/4 pi, which is 3 pi over 2. Okay, which is how I got these. Where is it? Oh yeah, these values here. Okay. But I think their way of doing it is a little confusing. But they're basically doing the same thing I'm doing. They're dividing the four equal segments and 4 equal intervals. It's just like those symbols, those X values for the key points is slightly different than the way I would do it. And so the endpoints of each subinterval that they create are the same as these values I got here for my key points. Those subintervals, the endpoints of the subintervals are the X values for the key points. So all my Y values, I do this approach. I change my X values first, and then I change my Y values appropriately. Okay. And what they did, they went and said, okay, 2 times 1/4 is 1/2, and at 1/2 you get 1. And so we're going to multiply 1 by 2, and so that'll give me at pi over 4, it's 2. So let me go through the process of doing what happens inside the function. And what happens inside the function is you're multiplying the y values by 2. So the 0 stayed 0, the 1 became a 2, the 0 stayed 0, the -1 became a -2, and the 0 remained 0. And so there they get the same ordered pairs that I had. And then we graph those points. We graph those points and then play connect the dots with a smooth curve. And then we extend it, and they tend to extend it a full period below and a full period above. So it shows the periodic nature of the beast. I prefer you do, well, at least half a period below and half a period above. So it shows the okay. Going the full period would be better, but at least half a period, if not the full period, below and above the initial or the primary cycle fundamental period. Okay. Now, something I forgot to do on this one is we know that sine is odd. So take the sign of a negative, you pull the sign, you pull the negative sign out, say it's the negative sign of the positive. So here we have a negative, no, it's not -4. It is 4 sine of a negative pi over 4x can be rewritten as the -4 times the sine of pi over 4x. And so now we can determine what A and the alpha and the amplitude is, and we can determine what omega and the period is. So tell me what A is.
Four.
Not 4. Well, this one here, because this is a function where this function and this function are the same. So this one is slightly easier to deal with than this one is. So what's A in this situation?
-4.
-4. The amplitude, which is the absolute value of A, is what?
4.
4. Yeah, a lot of people want to jump straight towards what the amplitude is. We always want to look what A is. Okay, A is -4. That's what we're going to multiply the y values by. We're going to multiply the y values by A. The amplitude just tells us how far above and how far below we go above the baseline. And the baseline in this case is going to be 0. So what's omega? We're dealing with the function over here. We pull where we pulled the negative sign out front because sign is odd.
Pi over 4.
Pi over 4. And so now we're going to find the period, which is 2 pi divided by omega. So 2 pi divided by, you're gonna divide by a fraction, right? What happens when you divide by a fraction? What do you do with it?
Multiply.
You end up multiplying. Multiplying by what?
The
2
reciprocal.
pi times what? What?
The reciprocal.
Yeah, the reciprocal. 4 over pi. Well, the pi's go to 1. They don't cancel, they go to 1. Canceling implies 0. And so so pi over pi is 1, and then we just have 2 times 4, which is 8. So t is 8. The period is 8. That means our x values go from 0 to 8. Halfway between is 4, and halfway here is 2, and halfway here is 6. So I have my between way here is 6. So I have my go to 1. They don't cancel in their head. They should be. And pi over 2, 1. And then at pi, it's 0. And then at 3 pi over 2, it's down to -1. And at 2 pi, it's back to 0. Okay. Now, these numbers here are my new x values. 0 stayed at 0, so 0, 0, 0. And now instead of 1/2 pi, it's now just the number 2, so 2, 1. Instead of pi, it's now 4, so this is 4, just the number 3 pi. Okay. Now these numbers here stayed at 0, so the number 2, 4, 0. Halfway between here is 4, 0. It isn't going to be able to do those because 8, 2 is now 6. This is about where 6 is. So 8's down that way somewhere. Okay. Here are my at 6 it's -1, and at 8 it's back to 0. 8 is out where 6 is. 6 it's negative. Okay. So I took care of what happens here with the 4 pi x. I multiply 4 pi x, pi over 4 by 1. No, I multiply by 2, and that gives me 2 over pi. I multiply pi over 4 times 4, that gives me pi. I multiply pi over 4 times 6, that gives me 6 pi over 4, which is 3 pi over 2. And then I multiply 4 pi 4 times 8, which gives me 2 pi. So these are pairs. Now I'm gonna attack with the amplitude or with the A. So I multiply each of my Y values by -4. So it goes to those pairs, or with A, 4 times 0 still 0, and -4 times 1 is a -4, and -4 times 0 still 0, and -4 times -1 is a +4, and -4 times 0 is still 0. No matter how many times you try to change it. So this is about 3. And this is about 6. And 6 way up there. It wasn't up there. And so that means this will be about 9. So this is going to be about where 8 is. And this will be about where 4 is. And 2 will be about here. So at 2, it's down to -4. And at 3, it's at 0. And at 4, it's at 0, sorry. And at 6, that +4 up here. Interrupt my writing up here. And then at 8, it's back 0. And here it's at 0. So it comes down to here. Goes through here and up to here, and it comes back down to move my point over to here. What would be better if I didn't have the pi markings across the bottom here for this? Yeah. All right, and this is kind of what they did here. Let me finish up this problem and then we'll call it quits for the day. Okay, they got the period. The graph lies between -4 and +4, which is what I've shown here. The cycle begins at 0 and ends at 8. That's what they calculated here for the period and for what A and the amplitude is. Okay, they divided the 8 by 4, and so they start at 0, 2, 4, 6, and 8 to find those 5 key points for the X values. And then they went through and calculated what each of those were. Yeah, I kind of like my way doing it here this way, because then I'm not having to trying to figure out what's happening to the X value, because I already know what happened to the X value. The X values for these 5 points became 2, 0, 4, 2, 4, 0, 2, 4, 6, and 8. And the Y values, which had been 1, which had been 0, 1, 0, -1, and 0, now became 0, -4, 0, 4, and 8. And 0. So I'm just multiplying each of these Y values by the -4, by the A, to get these values here. And I had changed my X values because I know what the period it is, and it tells me where those 5 key X values are. You know,
Just a heads up, Professor, it's minute 43.
I just wanted to finish this out for this problem. And those are the 5 key points, which we graph. And then we continue out 5 points. I mean, 1 period above and 1 period below. Okay. All right. So I'll go ahead and call it quits for the day because I'm over by 3 or 4 minutes. Please make sure you had put your name in chat before you leave. If you have any questions for me, don't hesitate to ask. Send me an email. You can ask me during class time. Okay.
You have a good day.
You too.
Have a good one,
Thank you,
Professor.
See you on Thursday.
I have a question or two
Yes.
questions.
Okay.
The first one is about the syllabus acknowledgement form because I tried to submit it, but I don't know where to submit it at. That's what the first question about. And submitting the syllabus acknowledgement form. And the second question about tutoring.
Oh, the tutoring. Well, here,
Right.
1 second. I gotta quit something out. Okay. Submitting what?
The syllabus acknowledgement form.
Oh, did I send it in announcements or did I send it as an email? Oh no, it was in files, right?
Yeah,
It should
that's
have been some, I either sent it as an email or files. You just send back an email stating that you've gone through you read through the syllabus and you understand all your responsibilities and everything it asks of you, and send it to me. That's all.
that's
As an
understood.
email. That's all you need to do.
I just didn't know which way to send it, but email will work.
Yeah.
I know how to send it by email.
So you can either download it and then print it up and sign it and then scan it back in, however, and send it back to me, or you just copy it in an email and change it appropriately.
Right. Because I have it right here, but I know I have to send it. Like I have it right here signed and everything. I just
Okay.
I
Yeah.
just have
Do you have a smartphone?
Yes, sir. I have it scanned. I just didn't know where to send it at.
All right. If you scanned it in as a PDF file, then just attach it to an email to me. Okay.
And tutoring.
Let me see. I think in announcements, and I'm going to send out an email to everybody later today. In announcement under welcome to pre-calculus. There are some things about, all right. There's 2 lists. Under the second list, number 4, it says student support. So you go into announcements, and it was the first announcement I sent. you click the student support and
Okay, I
it
see.
will take you to the campus resources and there's tutoring services there. There's the math lab, which is in the Gutierrez building. And then there's STEM, which is in the Brazos building, and they both have Zoom. You can have Zoom tutoring sessions with them.
Makes sense. I see the page right now that you guided me to. I appreciate that. I'm not
Oh
gonna
yeah,
take
no.
more of
Um,
the time.
Yeah, and I just today I got emails from both the STEM lab and from the math lab. And I'm gonna
Yeah.
post information about that. The STEM lab a person from the STEM lab wants to come and talk to my classes. And so they'll come here and talk to y'all about the tutoring services they provide. And you can, they'll probably give you links and emails and whatever, so you can do it that way. And the tutoring lab, the math tutoring lab, they have Zoom sessions you can jump into and ask people for help.
Yes, sir. Thank you, sir.
Okay,
Have a great one.
you too. We'll see you next time.